Hello viewers, welcome to this online session for postgraduate certificate in climate change. Today we are going to discuss about radiative forcing. So before that, I would like to give a brief introduction about the program. We are in the process of understanding atmosphere and climate, and then we have learned the differences between weather and climate and gaseous composition of the atmosphere, and also the vertical structure of the atmosphere and the importance of solar radiation, and also we have discussed the concept of greenhouse effect that has made our planet livable. There are many chemical anthropogenic emissions like chlorofluorocarbons. They were once considered safe because they are inert in the lower part of the atmosphere, that is troposphere. But once these chemicals enters the stratosphere, the ultraviolet radiation that can convert these chemicals into highly reactive species that can have a very devastating effect on stratospheric ozone. Similarly, anthropogenic carbon dioxide emissions, they are also coming from combustion process or incomplete combustion of fossil fuels. They were also considered safe because they are not toxic in nature as such, but the long-term accumulation of carbon dioxide in the atmosphere, they may cause to climate change that could then be harmful to humans as well as the ecosystem. This is the introduction part, and then before starting for today's lecture, so we have to recapitulate what we have studied in the previous session. That is, the one and the only source of energy that drives the climate system is the solar radiation that we have studied in the previous session. The main source of the energy which is available to the earth is sun's energy, and also the amount of the solar energy that is reaching the top of the atmosphere, which is primarily influenced by the many factors like the solar output, the altitude of the sun, and also the length of the day, and also the concentrations of the most of the greenhouse gases that have increased since the Industrial Revolution. So the effect of the human activities which are related to the use of fossil fuels, for example for the power generation, and also the agricultural activities, and also the land use change, that is mainly the deforestation, which are considered as the main driving force for the increase in the greenhouse gas emissions. In fact, three greenhouse gases like carbon dioxide, methane, and also the nitrous oxide, they have increased remarkably in the atmosphere because of the anthropogenic activities since the pre-industrial period. So now we will be looking into the today's topic of discussion, that is radiative forcing. So you must have already read and then know about this radiative forcing that comes under the types of impact and the assessment protocol. Scientists have already observed many changes in the Earth's climate in every region across the globe on the whole climate system. Recently, we have seen that the latest Intergovernmental Panel on Climate Change, that is the IPCC report, which is released on 9th August 2021. So the report shows that the emissions of greenhouse gases which are coming from the human activities, they are responsible for approximately 1.1 degrees Celsius of warming since 1850 to 1900, and finds that averaged over the next 20 years. So the global temperature is expected to reach or maybe exceed 1.5 degrees Celsius of the warming. So this assessment is based on the improved observational data sets to assess historical warming as well as the progress in scientific understanding of the response of the climate system to human-caused greenhouse gas emissions. So there are many characteristic features of climate change which are directly depend on the level of global warming. For example, warming over land which is larger than the global average, and it is more than twice as high in the Arctic region. So scientists have already warned us that the carbon pollution and resulting the climate change, which are expected to lead to more intense hurricanes and storms, heavier and more frequent flooding which we are experiencing now, and increased drought and more severe wildfires, These are the events that can cause deaths, injuries, and billions of dollars of damage to the property and the nation's infrastructure. At any given point of time, the Earth's climate is subject to a number of influences. These influences generally we are calling them as forcing or drivers. So some of them are natural and some may be caused by human beings. So now we will look into the drivers of climate change. So first we have to discuss about the natural drivers. So in that, the very first natural driver is the solar variability. So the name indicates it is the solar variation. That means there is a change in the sun's radiation output. The sun is fundamentally the source of all energy on the earth. We all know that and we are experiencing. And regardless of other limiting and any amplifying factors. So if the amount of radiation from the sun which is changed, then it has a knock-on effect on the isolation and also on the temperature. So the radiation may vary in both quantity as well as the quality. So if we will think about the quantity, that means the amount of radiation. But if we will think about the quality, it is a type within the spectrum, that is the type of ultralight emitted from the sunlight as well as the quantity of radiation which is normally varies through the amount of activity that's seen upon the sun's surface, which can manifest as a sunspot. So you must have gone through that. What are those sunspots? That is an isolated area on the sun's surface that is cooler and also it is visibly darker in color. So sunspots are generally twice the diameter of the earth. So you have to imagine and then visualize the sunspots. So they generally form in pairs and also at significantly cooler temperatures of the around, I think, 4240 kelvins, and when compared to the regular temperature of the sun's surface at approximately 6000 kelvins. So sunspots can form in groups up to 100 and can also may vary up to 2 months. So the occurrence as well as the prevalence of sunspots, they have taken on regular cycles which are commonly known as Hale cycles. So these Hale cycles have a periodicity of 22 years. So the cycles describe the magnetic intensity upon the sun that itself correlates with the sunspots. So the magnetism switches polarity within the 22-year period. So the polarity itself does not influence sunspot member, and also so we can observe them upon almost an 11-year cycle. The total energy which is emitted from the sun is highest at a sunspot maximum when the greatest amount of sunspots are present. That means similarly the earth receives the slightly more. But between a maximum and a minimum energy output, that only varies 0.1%, which is calculated from the 20 years of records that exist on this matter. For instance, changing the solar energy that might change the oceanic surface temperature, that could increase evaporation and also in turn it contribute itself to the greenhouse effect. And another factor, that is a water vapor, that itself is the most prevalent greenhouse gas in the atmosphere at about, I think, 0.3% of the mass of the atmosphere, but only 0.06% for carbon dioxide. So the radiative forcing for carbon dioxide and water is not at all equal, but models shows that water vapor contributes to around, I think, 60% of the greenhouse gas effect. So we can extend this reasoning to realize that it is not just solar variation that can influence water vapor, but also things like land use or any other factor that could affect evaporation. But it is also important that we have to understand it is a feedback system. That means water vapor will adjust along humidity, and also whenever the earth warms for a given reason, water vapor will also rise and also amplify the effect of warming. So it can be deemed a contributing amplifier. So our sun is a small star we have to understand that with remarkably stable energy output. But there are many stars are existing. So their pulse is dramatically in size also and brightness, but there is a change in our sun's luminosity that is varies only about 0.1% over the course of its 11-year solar cycle. But these small change in incoming radiation which exceeds all other energy sources like radioactivity from the Earth's core, so it is important to consider. So the change in extreme ultraviolet radiation that can be particularly important, that varies by a factor of 10 or more. So this extreme ultraviolet radiation that can affect the Earth's upper atmosphere during solar maxima by creating more nitrogen oxides, that in turn can reduce the ozone levels by few percent. That results in more UV radiation which reaches the Earth's surface. So solar cycle, that forcing seems to affect the general circulation more than having a direct temperature signal with an increase in the precipitation, the most likely outcome. So one major connection here, it is known as Maunder minimum, which is of these late 1600 and early 1700 it has been experienced, which was the coldest part of the Little Ice Age. So this period was characterized by bitterly cold winters in Europe and also the North America, although there wasn't actually any glaciation. So the solar cycles during this period were extremely weak, which is based on the number of sunspots that they have been observed. So the number of sunspots, they have risen steadily since the late 1600s, which many scientists believe that this has contributed to as much as the half of the 0.6 degrees temperature that increase since 1900. However, there is still much uncertainty in these estimates. So it is possible that we are now in a minimum version of the Maunder minimum, as solar activity is the weakest it has been in more than 50 years and also has reached a pronounced minimum in 2020. A weaker minimum that is predicted by around 2031, so we have to think about that. So the current reduced sunspot cycle that has not resulted in any apparent decrease in global mean temperatures. So research suggests that there is an inverse correlation between the length of sunspot cycles and also the magnitude of the Earth's warming or cooling during the next sunspot cycle, that is the longer cycles, that is equals to cooler average temperatures. So based on this type of research, a drop in an average temperature during current solar cycle number 24 of about 1 degree centigrade, which is possible for parts of the globe. So obviously this is not happened yet. So time will tell us that if this prediction technique is reliable or not. Although the sun's energy output has been reliably steady, there is historical evidence for relatively cold periods which are caused by the reduced solar luminosity. So the frequency of these sunspots and the lengths of sunspot cycles seem to have some relationship to global temperatures. So an increase in the number of sunspots may have contributed to a portion of the observed global temperature increase over the past 150 years. So forecast of solar activity that suggests that some cooling may occur in the next 2 decades as a result. So now we will see that the second observation, that is the orbital variations. So in orbital variation itself says that our lives literally revolve around these type of cycles. There are series of events which are repeated regularly in the same order. So there are hundreds of different types of cycles in our world and in the universe also experiencing. Some may be natural, like changes of the season, and then annual animal migrations are the circadian rhythms that govern our sleep patterns. So some others are also there that are human produced, like growing and harvesting crops, and musical rhythms are the economic cycles. So cycles means they play very key roles in everything of the Earth's short-term weather as well as the long-term climate. A century ago, a Serbian scientist, that is Milutin Milankovic, he hypothesized the long-term collective effect of the changes in the Earth's position, which is relative to the Sun, are strong drivers of the Earth's long-term climate, where they are responsible for triggering the beginning and the end of the glaciation periods, which are normally we can call them as ice ages. So specifically, he explained how these variations in three types of Earth orbital movements that affects how much solar radiation, and this is also known as the insolation, that reaches the top of the Earth's atmosphere as well as the isolation reaches. So these cyclical orbital movements, which became known as the Milankovitch cycles, that causes variation of up to 25% in the amount of incoming insolation at Earth's mid-latitude, that is approximately the between 30 to 60 degrees north as well as the south of the equator. So the important features of this Milankovitch cycle are the very first one is the shape of the Earth's orbit. Normally we can call them as an eccentricity, and the angle of Earth axis that is titled with the respect to the Earth's orbital plane, that is known as the obliquity. And the third one is the direction of the Earth's axis of rotation is pointed, known as the precession. So in astrodynamics, the orbital eccentricity of an astronomical object is a dimensionless parameter that determines the amount by which its orbit around another body deviates from a perfect circle. So there are series of events which are repeated regularly in the same order. There are hundreds of different types of cycles in our world and also in the universe. Some are natural and also some may be changes of the seasons and animal migration, what we have already discussed. So now we will discuss a little bit deeper concept of the eccentricity. So Earth's annual pilgrimage around the Sun, it is not perfectly circular, but it is pretty close. So over a period of time, the pull of gravity from the solar system, that is the two largest gas giant planets like Jupiter as well as Saturn, that causes the shape of the Earth's orbit to vary from nearly circular to slightly elliptical in shape. So it measures how much the shape of the Earth's orbit that departs from a perfect circle. So these variations which affects the distance between the Earth and the Sun, and also the reason why our seasons are slightly different lengths, with summers in the northern hemisphere currently about 4.5 days longer than winters and springs about 3 days longer than autumn. So as eccentricity decreases, the length of our seasons gradually evens out. So the difference in the distance between Earth's closest approach to the Sun, which occurs on about January 3rd each year, and also its farthest departure from the Sun, that is known as the aphelion, are about July 4th, is currently about 5.1 million kilometers. So a variation of 3.4%. So that means each January about 6.8% more incoming solar radiation that reaches Earth than it does in July. So when Earth's orbit, which is most elliptic in nature, and also about 23% more incoming solar radiation that reaches Earth at our planet closest approach to the Sun each year than does its farthest departure from the Sun. So currently Earth's eccentricity is near its least elliptic, that is mostly circular, and is very slowly decreasing in a cycle that spans about 1 lakh years. And the third natural process is the tectonic process. So the horizontal and the vertical displacements which are associated with the plate tectonic plates, that plays a crucial role in climate change over a wide range of time scales we have experienced and then we will be experiencing. So the solid Earth surface, which is direct contact with the atmosphere, and also oceans and its evolving character that affects balances of the incoming and the outgoing radiation. and then atmospheric circulation, ocean currents, and the location of elevated terrain which is suitable for glaciers and ice sheets. So tectonic processes, they have important indirect climate effects through their control on geochemical cycling and the composition of the atmosphere and the ocean. So this entry which provides an introduction to the more direct physical effects of the tectonics on the climate system. So a number of tectonic processes which are linked both directly as well as the indirectly to a wider range of climate forcing. So the direct role of plate tectonics in specific ancient climate events is generally difficult to decipher. So in addition to that, the direct climatic effects of horizontal and vertical tectonics and then paleogeography strongly influences the climate system's sensitivity to external forcing, and that provides the basic framework for studying ancient climate change over geological timescales. So learner, we have to understand the relative contributions of greenhouse gases concentrations and also plate tectonics in the evolution of the Earth's climate that continuously to be debated, and also we have to act upon it. So the tectonic processes that influence the composition of the atmosphere, so the two cannot be entirely separated. So tectonically forced changes in ocean as well as the atmospheric circulation, they have greatly influenced on the evolution of specific regional climates. Their potential to produce the full range of global climate variability that recognized in the geologic record that may not be as great as once suspected. The tectonic processes are usually associated with slowly evolving environmental change. There are important exceptions also there. And then here we have to think about volcanisms, that is essentially instantaneous effect on the atmosphere. Here volcanism essentially instantaneous effect on the atmosphere provides one example. So it is very less obvious, that is the climate system's potential to respond non-linearly to the most gradual tectonic forcing. Sometimes it may be sudden and extreme consequences. So that is why plate tectonic process should be considered a potential climate forcing mechanism on all time scales. So we will see that what is the volcanic eruption. So what will happen? So the predictions which are emerging from the latest report by the Intergovernmental Panel on Climate Change, there is a ray of hope. That means a major volcanic eruption can restrain anthropogenic global warming to a smaller extent. So in that report they have mentioned that all statements about global warming violation, that is 1.5 degrees Celsius rise over pre-industrial levels, that assumes that no major volcanic eruptions that occurs in the near term. So before the end of the century, there will be at least one large volcanic eruption. So the scientists predicted, which is based on their study of ancient climates and also the historical evidence. So such type of eruption will reduce global surface temperature for several years. It is an interesting, and also it decreases the land precipitation, and it can also alter the monsoon circulation and modify extreme precipitation at both global as well as the regional scales. So an increased number of volcanic eruptions that are resulted in a consistent slow cooling in the northern hemisphere from 1450 to 1850. So the researchers have already studied and then observed. So the cooling showed regional variations unlike the global warming that begin immediately after. So what is meant by the cooling effect? So what is the science behind this cooling effect? So we have to understand that there is a large volcanic eruptions shoot out aerosols, that is we all know that there are some of the liquid particles, some of the solid particles into the upper atmosphere. So these reflect the sunlight and induce a long-term cooling effect on the surface. So this normally we can call it as an albedo effect, that is an increased reflection of the sunlight that is produced by the aerosols that have shown to partially offset of that warming in that atmosphere dense with the greenhouse gases according to the some of the climatic models. So the combination of these two factors, which is showed down that global warming between 1998 to 2012 when compared to the three preceding decades. So the research shows that a warming of 0.87 to 1.22 degrees Celsius over the period of 1906 to 2005 due to the greenhouse gases was partially offset by cooling, this type of cooling effect, that is 0.54 to 0.22 degrees, 0.22 degrees. By cooling of 0.54 to 0.22 degrees Celsius, which is attributed to the aerosols. So the effect of these natural triggers, however, are negligible in nature and also in the long term in comparison to those resulting from the human activities. So we have to think about this. So the volcanism, which is an impact on precipitation, for instance, large volcanoes eruption in one hemisphere that can enhance the global monsoon precipitation also in the other hemisphere. So these are the natural drivers of the climate change. Learners, so far we have studied the natural drivers of the climate change like solar variation, orbital variation, as well as volcanic eruption, as well as the tectonic process. So all these are the natural drivers for the climate change. Anyway, climate is changing. So the main concepts we have understood. So in the next session, what we can discuss is some of the anthropogenic drivers of the climate change, where we are mostly concerned about it. I hope you must have benefited with this session. So in the next session, we'll come up with the anthropogenic drivers. Thank you.